Hey everyone, just to let you know, I just finished grading exam number 4, which you took yesterday. I gave you 20 problems. Now I'm going to go over these 20 problems. Many of you asked me for tutorial, but it took me long because I just finished making the tutorial for AP Physics exam 4. Now I'm going to give you the Einstein competition 1 on Wednesday, November 5, and on Friday, November 7. If you win at least one Einstein competition, all the exams and all the quizzes you took in MP1, I will adjust them to 100. But to win the Einstein competition, you need to understand everything from exam 4, mostly exam 4 and beyond. So here is the exam 4 tutorial. Also, I'm going to do it. The problem number 1 is a construction problem, so I'm going to do it on the paper, but here's the idea. I gave you scaling factor 1 centimeter is 8 meter. You move to 16 meter to the east. Remember to use this convention: east, north, south, west. So 16 meter, which is you're going to use the ruler to do 2 centimeters. I ask you to go to 24 meter, which is 3 centimeters, right, to the north. And I ask you to go to 8 meter to the west. 8 meter to the west, which is 1 centimeter. And then I ask you to do the resultant. The resultant is the displacement. Displacement is the shortest distance between the initial point and the final point. I'm not going to use the, maybe I can use the ruler if I do have the ruler. Yeah, I have the ruler. Okay. Shortest distance between these two paths. But don't forget the arrow. Okay. So this is called displacement or resultant. This is the resultant angle. You can use the protractor to find this angle. 16 meter to the east. That means I have to draw 2 centimeters. So make sure I draw 2 centimeters. I'm going to start from here. I supposed to use the pencil, but let's see. Hopefully I'm not going to make any mistake. So this is 2 centimeter. This is 0 centimeter. So from 0 centimeter to 2 centimeter, this is my 16 meters. Now I'm going to do 24 meter north. So if 1 centimeter is 8, then 24 meter is 3 centimeters. So I'm going to go to 3 centimeter to the north. So I'll go 3 centimeter to the north. Since they are vector, I'm going to make sure they have the arrow. Now I have to go to 8 meter west. That means 1 centimeter to the west. I'll go 1 centimeter to the west. Okay. All right. Now what I know is this is the initial point and this is the final point. Displacement is the distance between initial and final. So I'm going to just connect these two and make sure I have the arrow. If I don't have the arrow, then this is not a vector. This is a displacement vector. Now I also ask you to give me the angle, resultant angle. This is called a resultant vector. This is also called a resultant vector. Displacement, but also called resultant vector. How much is the resultant vector? I ask you to find that for me. So take the ruler over here. Is 3 centimeter. So you're going to write 3 centimeter, which is 24 meters. So this is 24 meter. 24 meter. See 72 degree. So this is 72 degree. Okay, so let's solve the next one. Next problem is problem number 2. So problem number 1, that's all I ask you to do. Problem 2, a toy car initially moving 2 meter per second. That's how you're going to write it down. Uniformly accelerate. So the velocity final is 8 meter per second. That means it had to accelerate. Otherwise, you cannot have velocity increase. Without acceleration, the velocity 2 meter per second will forever be 2 meter per second. So it had to accelerate. Okay, now for the distance of 10 meters. So if you want to see the picture, this is what's going on. In the beginning, it was moving 2 meter per second. At the end, it is moving 8 meter per second. That means it had to accelerate. And that's what we want to try to find. And accelerate for how long? 10 meters. Now, one equation that going to give you the answer right away is VF squared is equal to VA squared plus 2AD. VF squared is 80 squared is equal to VA squared is 2 squared plus 2A, and D is 10. So you have 64 minus 4 is equal to 28. So 60 is equal to 28. So A is equal to 3. So we found the answer. So we're going to write 3. 3 what? Meter per second squared. Now let's go. We solve number 1. We solve number 2. Now let's solve number 3. So number 3, we're going to change the color. So again, this is a similar problem. A car moving 20 meters per second, that's your initial velocity, 25 meters per second, is uniformly brought to rest. That means the car this time is deceleration. Initial velocity is 25 meters per second. Final velocity is always use the picture if you want to understand the problem 100%. So acceleration must be this direction. So velocity is this direction, acceleration is this direction, object is slowing down. Object cannot slowing down without acceleration. In this case, it's deceleration. We want to try to find the magnitude of that acceleration. How long did it work? 40 meters. It deaccelerate for 40 meters. So you're going to use the same thing. BF squared is equal to VI squared plus 2AD. BF squared is 0 squared because it comes to stop. VI squared is 25 squared plus 2A. We are trying to find D is 40. Now, you have a calculator over here. So I have 25 squared is equal to 80. Divide by 80. So 25 squared divided by 80, which is 7.8. So 7.8 meter per second squared. Of course, in this direction to the west. To the west. This time I did not ask you for that. So just write 7.8 meter per second squared. All right, you need to always write outside the box. It's easy for me to read and it doesn't get crowded. That takes us to problem number 4. So we're going to solve problem 4 now. We're going to go to the next page now. All right, now that takes us to problem number 4. Problem number 4, Mr. Berry is on the top of a 40-meter tall building. He throws something with 22 meters per second at 90 degree. At t second later, this one gonna fall here, right here. Now the problem asking you that this is higher than 40 meter. This one higher than 40 meter, but this time he's not gonna throw up. He's gonna drop, right? He's gonna drop it. Okay, but both of them are gonna at the same time be drop from higher height, right? Okay, so but this this t and tb, this is tb, ta is equal to tb. So what is this height actually? It's more than 40 meters, but what is actually it is? So let's first find the time ta, so then we can figure that out. So you have 40 negative 40 is equal to 22. T is 22t minus 5t squared. So you have 5t squared minus 22t minus 40 is equal to 0. So you have 22 plus minus 22 squared minus 4, 5, 40. This is minus. Okay, so you have 22 squared. You have this is plus 800 and square root of that 35.83. 35.83 plus 22, 57, divide by 2 times 5, and that is 10. So divide by 10, and that is 5.78. So if d is equal to half a t square, so d is equal to negative 5t square. So d is equal to negative 5.78 square. I don't know how much is that. Well, let's see, times 5. So that 167 minus 40. So 127. So the answer is 127. So that is problem number 4. So we're going to write 127. 127 what? Meter. Put the SI unit outside, so it's going to be easier for me. Let's go over problem 5. Problem 5, many of you are having problem with problem number 5. So let's go over problem 5. So this is problem 5. The first one is dropped from, so I ask you to draw this. So to draw that, you have to draw, I ask you to draw the what? Draw the VT graph. So I'm gonna have you draw the VT graph. So the first one doesn't need any quadrant except the quadrant 4. The second one does not need any quadrant except the quadrant 4. The third one do need quadrant 1 and 4. So we're going to call V, V, V. This is T, this is T, this is T. The first one, if you read it carefully, then you will see the first one dropped from rest height 30 meters, right? So this one, when you drop, initial velocity is 0. So we have to start from here. 30 meter, right? Okay. So dropped from rest for 30 meters. So that's very easy. So we have to find t. T is what? 2d over g. So 6t over 10. So t squared. So 6. Square root of 6 is 2.4. So this is 2.4. So this is 2.4. Now we know velocity final is equal to velocity initial plus at. This guy is 0. So at negative 10, 2.4. So this is negative 24. So this is negative 24. So we know what to do. We're just going to connect it. If I have a ruler. So I'm going to connect it. This is good. This is good. So I'm going to connect this too. All right, that's it. That's the first one. But I ask you to shade it. So make sure you shade it. If you don't shade it, I will not give you the point. Okay, the next one is, let's read. Thrown downward with initial velocity 25 meter per second. Downward 25. So we're going to make it the negative 25. So downward. So this slope and this slope now going to be the same. So how I'm going to do that? I can figure it out by using this angle, then the slope going to be the same. So what angle is this one? I see I should have chosen a better angle than that. Okay, this is 30 degrees. So I'm going to make it 30 degree from here. So 30 degree from here. Where is 30 degree? 30 degree from here. So here. Okay, so I'm going to now connect them. Oh, I have to have the time. So what is the time? Okay, so what's going on? What is the height? 330 meter. So okay, 300 negative 330 is equal to negative 25 t minus 5t square. So you have t is equal to 6 seconds. So I'm going to write 6, and Vf is equal to Vi plus At. So Vi is negative 25 minus 10, T is 6. So negative 25 minus 60, wow, 85, negative 85, negative 85. So I'm going to go right over here and I'm going to connect them. Again, I ask you to shade area under the curve. So make sure you do shade area under the curve. So, okay. Now the last one is, what does it say? Thrown upward 25, 30. So this is 30 meter. So negative 30 is equal to 25t minus 5t squared, and that is t is equal to also 6 seconds. Now we have to find the final velocity as well. Initial velocity is 25. Final velocity is Vi is 25 minus A is 10, T is 6. So 25 minus 60, negative 35. So this is negative 35. So you're going to connect this this one and this one. Okay, so we connect like this. All right. So now many of you made a mistake when you shade area under the curve. So this is area under the curve. All right, and that is problem number 5. Now let's go over problem 6. Problem 6, let's read it over here. Problem 6, Mr. Barry threw a ball straight upward with 25 meters per second from 30. We already know because we did the same thing over here. 25 meters per second from, no, we did not do, oh yeah, okay, throwing upward. So we already know that takes 6 seconds. So we can use that information here without doing it. So that's called saving time. All right. So this is, you want to throw off throwing up with 25 meter per second, 90 degree, 30 meter. So T must be 6 seconds. Now the second part say, at the same instant, ball B is dropped from a rest higher height, exactly the same thing, above the ground. Choose H, that the ball have the same impact speed. They both have the same impact speed. This is bigger height. Okay, so what is the impact speed over here? Vf is equal to Vi plus At. You did it before. I think negative 35 is 25 minus 10t, right? So it's negative 35. So impact velocity here has to be negative 35. To have negative 35, remember this you dropped. So negative 35, this is 0. Your time has to be 3.5. So we want to find the h. Now d is equal to minus 5t squared. So d is equal to minus 5, 3.5 squared. So the height is times 5, and that is 61.25. 61.25. So now I'm going to go over here and I'm going to write 61.25. Of course, don't forget to write meter over here. Now let's go problem number 7. Problem 7. Problem 7. Mr. Body throw. Okay, it's the same thing. Wow. See, that's why I really wanted to help you out. So I don't really care about you saving time. I care about you understanding the concept. So we done number 6. We done number 7. No, we are doing number 7. Number 7, Mr. Body throwing a ball upward. I don't know whether you see it. Okay, yeah, you see it. Mr. Body throwing a ball upward, right, with 20 again with 90 degree, 25 meter per second, and it's going to hit the ground at t is equal to 6 seconds because we solve it right before the problem. Yeah, right here. And this is 30 meter, right? Okay, that's scenario 1. Scenario 2, at the same instant, ball be dropped from rest higher height. We already know higher height. Exactly the same. Higher height is 330. The problem before. Uh, how do you know higher height? At the same instant, ball B dropped from rest from higher height H above the ground and C thrown down from K. H and K show that the ball touched the ground at the. Oh, wow. Okay, so I give you the same thing. So what is the height of this one? If the TA is 6, TB is 6, and TC is also 6. So what I wanted you to assume that if the initial velocity is 25 over here, initial velocity is negative 25 over here, and initial velocity is 0 over here, because I said this is throwing down and this is drop, and this is throwing down. So I wanted you to assume the same thing. Okay, now what is the height of this one? To find the height of this one is very easy. If it falls for 6 seconds, d is equal to minus 5 6 square, and that is 180, and d is equal to minus 5 uh, what about this one? No, this one has the vi, so d is equal to vit plus half at square. This one vi is 0, so I have to add that. So negative 25 t is 6 minus 5 t is 6 square. So this is negative 25 times 6 is equal to 150, and minus this is about, I believe, 6 squared times 5 is 180. This is minus, so 150 plus 180, and this is 330 minus. So the answer is this one is 180 and this one is 330. So if you write negative 180, negative 330, that's also fine, doesn't really matter. Okay, now number 8. Okay, so we're gonna solve problem number 8 now. Okay, problem 8. Mr. Bari stands on again. Ball is for okay. So find the common time of impact. Oh God, this is same thing. All right. So scenario 1. Initial velocity is 25, angle 90, distance 30 meter. So t has to be 6. We solved it many times. At the same instant, ball B is released from rest 180 meter above the ground. We just solved it. V initial is 0, 180 meter. So this must be nothing but t is equal to 6 seconds. And this one fall 330 with initial velocity negative 25. So this has no option but t is equal to 6 seconds. So the answer is 6 seconds. Wow, this one was really cool. Second. Okay, now this problem is also very easy. You see that I'm going to do it here if I can. Now, you know this function is just v is equal to 20. This function is same, but this function is, as you see, v is equal to t. How do you see v is equal to t? Because 0 comma 0 and 20 comma 20. So as you know that 20 minus 0 is 20 and 20 minus 0 is 20. The slope is 1. So vf is equal to vi plus at. So this is x and this is y, right? So at 0, acceleration is 1, t minus 0. So vt is just t. So you're going to say this one has the equation vt is equal to t. So at 40, 0.01, this one 40.01. So now 40.01, we can draw the graph. You extend it a little bit, not much. 40.01 gonna be, I'm exaggerating a little bit. So 40.01 is gonna be okay. So 40.01 is gonna be here. So this is gonna be 40.01. Why I wanted you to do that? I want you to show that the car X and Y. The car X and Y at 40 second and 40.01. At 40 second, they both have 800. At 40.1, this one has 800.4, and this one has 800.2, and this one has 800.4. So anytime after 40 seconds, the car Y go ahead of car X. How do I know this is 800.4? All you need to do, area, this one is half 40.01 times 40.01, and that is this one. How do I know this one? BH. B is 40.01 and H is 20 because it doesn't is never changed 20. And this gives us this one. So yeah, anytime after 40 seconds, the car Y passed the car X. Okay, that takes us to problem number part 2. Again, throwing up. So 20 meter tall, and you throw off with 10 meter per second, and is eventually come to the ground. You want to know, what do you want to know? What happened after 3 seconds? Okay, so 3 seconds. Let's see the impact time at the ground. So you have negative 20 is equal to 10t minus 5t squared. So you have 5t squared minus 10t minus 20 is equal to 0. So t squared minus 2t minus 4 is equal to 0. So you have negative b plus minus b squared minus 4ac over 2a. So now you have 2 plus minus 4 minus 4, a is 1, c is minus 4 over 2. So 2 plus minus, you have 20, square root of 20, right? So square root of 20 is 4.47. So 2 plus minus 4.47 divided by 2. So plus 2 divided by 2, and that is 3.2. So 3.2. All right, so we need to find the velocity at 3 seconds. So here is the velocity. If this is 3.2, this is 3. So what is the velocity over here? That is easy. Vf is equal to Vi plus At, and that is Vi is 10 minus 10, 3, so negative 20. So this is negative 20 meter per second. Now the next one is tricky. I ask you to find the distance line and displacement line. Okay, although I draw it like a parabola to show the different characteristics of the graph, when I say it is 90 degree or throwing upward, then there is no parabola. It goes up, stop, and return. Location A, location B. I cannot say, I cannot make other location C, because in order to make the real graph, if I make a parabola, I can show loss of location 1, 2, 3, 4, 5, 6, 7. That's the reason I draw it like this. I exaggerate. Here it look like there is a range, but actually there is no range. It doesn't move in that direction. It goes from your hand and comes back to your hand. Okay, so now what is then distance? This is the distance line. What is the displacement? This is the displacement. Okay, so you're gonna draw it. This is distance, this is displacement. Okay, you're gonna find the distance and displacement. Well, that's very easy. It is equal to VIT plus half AT squared. To find the displacement at max height, we have to draw it like a parabola. Okay, so VF, this is just model to solve the problem. You have to exaggerate when you have to. VF is equal to 0, so this is max height. Okay, so VF is equal to VI plus AT. What is the time at max height? So max height time is 1. So here time is 2, but we don't need time here. So we're just going to plug in 1. So you have the 5 meter. Distance is 5 meter. So distance is 5 meter. Displacement is also 5 meter, but it's to the north. I did not take away point for not writing north. So this is the distance. This is the displacement. Okay, number 13. Find the acceleration. Oh, acceleration, by the way, is same everywhere. Acceleration here, acceleration. Acceleration is same everywhere. This is called field, gravitational field. The strength of the field is same everywhere, which is -10 meter per second squared. So -10. Number 14, find the range. The range, there is no range. If it goes up and return, there is no range. It doesn't move at the x direction. So dx is 0 meter. Find the impact speed. We already found the impact speed, 3.2. No, not, oh, time, we found the time. Okay, time is the, so impact speed BF is equal to VI plus AT. So VI is 10 minus 10, 3.2. So 10 minus 32, so 22. Impact velocity is -22. Don't forget the negative meter per second. So now we are coming to 16. Find the position 5 to 5 seconds. So where is 5 seconds between 4 to 6? So 4 comma 2 h and k, 6 comma 4 x and y. So y is equal to a x minus ac square plus k. Y is 4, x is 6, h is 4 square plus k is 2. So you have 2 is equal to 4a. So a is equal to 2 over 4 half. So y is equal to half x minus 4 square plus k. So our position function is half t minus 4 square plus 2. I did not ask for position function. I ask you what is the position at 5 seconds. Half plus 2, really? 5 over 2 is 2.5. So the position is 2.5 meter. I already put the SI unit so you cannot make mistake. Now find the velocity at 5 seconds. Now here from 2 to 4, so it covers the distance of 2 meters. So that means the whatever the area is has to be 2. So area is half BH. Area has to be 2. Half B is 2. H is velocity. So velocity is 2 for between 4 to 6. So this is velocity. Velocity initial is 0. Velocity final is 2. So this area has to be 2 now. I want to find the velocity not at 6, which is 2, not at 4, which is 0. I want a velocity at 5. How can I find it? By creating velocity equation. So I have 4 comma 0 and I have 6 comma 2. So VF is equal to VI plus AT. So VF This is t, this is v. Velocity is 0 at t equal to 4 seconds. Now acceleration is what? 2 minus 0 divided by 2, 1. Acceleration is 1, t minus 4. Okay, that's it. So Vf is equal to t minus 4. So at 5 minus 4, which is 1. So we're going to write 1. Now acceleration at 11 seconds. 11 is between 10 to 12. So at 10, you see is 2. At 12, you see is 1. So it covers only 1, negative 1 meter. So that means the area, whatever here is, has to be negative 1. So area is half BH. So half, this is negative 1. So negative 1. So the velocity over here is negative 1. Right? Velocity over here is negative 1. Velocity over here is 0. So this area we are talking about is negative 1. So this is negative 1. This is 0. So what is the acceleration? Vf minus Vi over 2. Vf is 0 minus 1 over 2. So minus plus 1 over 2. So 1 over 2. That takes us this problem which I showed you last time. But I changes just the value. Not going to change anything. So what is the area over here? Area is half BH. Area is half. B is, this is 1. So I'm going to write 1. H is, this is 2. So I'm going to write negative 2. Actually, this is negative 2 because this is below 0. So this is negative 1. If you want to include this one, you multiply by 2. So this is negative 2. So area of this one is negative 2. So then there exists, let's see, let's first find area here. Then we can talk about it. Area is half BH. If this one is positive 2, then exactly at 4 seconds the object returned to the origin, but I don't think that is the case. And H is 4 minus 2 is 2, and H is 4. This is 4, double. So there exists a T over here where the area is plus 2. So plus 2 minus 2 is 0. So at that T, the object is back to origin. Now let's see what is that T. That T must be any value between 2 to 4. That T, any value between 2 to 4. Okay, let's find that T. So area is half BH. Area is T minus 2. Why T minus 2? Because we don't want to include anything that is before 2. H is, we have to find first the acceleration because this is velocity. And velocity is AT. Right? This is velocity. So half T minus 2. Velocity is AT. So half T minus 2. Acceleration is what? If this is 4, 4 minus 0 is 4. 4 divided by 4 minus 2, 2, which is 2. And T is T minus 2. 2 to cancel. 2 minus 2 square. Alright, so now we're going to write, don't forget negative 2. Negative 2 plus T minus 2 square is equal to area. So T minus 2 square is equal to negative positive 2. So you're sending over there. Square root. So T minus 2 is equal to square root 2. So t is equal to 2 plus the square root of 2. So 2 plus the square root of 2, which is 3.4. So this is 3.4.